Hi, my name is Henry. I am here to show you everyone how to solve absolute values here with Think Academy. So as you can notice right away, we need to actually talk about what exactly is inequality. Jenny, can you tell me what exactly is inequality? Yes, that's right. It's a measure of how far away a number is from the line zero. So, take for instance, everyone's favorite number, right? Seven, lucky seven. We can have both a positive and a negative seven. And if I try to find the absolute value of that, it's always going to be positive. Oops. Sorry, I forgot to mark that as a negative seven. So it doesn't matter if it's indeed a positive seven or negative seven inside the absolute value sign, is going to be positive. In fact, you can have negative seven here, and that's going to be 7 units that way to the right. And then I have seven, positive seven here. I'm going to go to the left 7 times. Of course, to meet up at zero. So precisely zero, all absolute value is telling us is how far away a number is from zero. And thus absolute value is going to be positive. So now we have a situation here where we have to solve for absolute value inequality of absolute value of 2x minus 3x is greater than 1. So John, can you tell me what exactly here you think we should do? You don't know? Okay, how about Jimmy? Can Jimmy help him out? Jimmy. Yes, well done. So indeed, Jimmy, we're gonna have to set up something called cases. Absolute value we have here positive and negative. So we're gonna have to do the same. We're gonna have a case for it when our absolute value is positive or when it is negative. So I'm gonna do my first case here in red, my second favorite color. And my absolute value I know is 2x minus 3 is greater than 0. So greater than or equal to 0. So I can actually solve this. I can say, okay, well, my first condition here, my first case is I'm going to try to see what exactly I get when I solve my inequality. So I'm going to go ahead and add 3 to both sides. So 2x is greater than or equal to 3. Now I'm going to divide both sides by 2 exactly, but great job, Amber. You said it perfectly. You said that we do not have to flip the inequality symbol. You remember from last class. So I'm going to leave it exactly the way it is, and I'm going to go ahead and divide both sides by 2. I'm not going to change that inequality symbol yet. Keyword. We're going to get to that eventually, but not right now. Greater than or equal to 3/2. So let's see if our problem we have that they gave us, the 2x, the absolute value 2x minus 3x is greater than 1. There's multiple ways to solve this. I'm just going to go ahead and do the easy way first. I'm just going to do plus 1, because this is positive. 2x minus 3 minus 3x is greater than 1. This is what we're trying to prove with this condition. So I'm going to go ahead and I'm going to multiply. So 1 times 2 is 2x, of course. And 1 times negative 3 is indeed, that's right, John, negative 3, because I'm multiplying a positive and negative number. Negative is always going to win out just that once, right? Minus 3x is greater than 1. So I'm going to go ahead and take my 2x here, my minus 3x. I'm going to combine my like terms. So I'm going to get negative 1x here. Minus 3 is greater than 1. Then I'm going to add 1 to both. Sorry, not add 1. My apologies. I was looking at something wrong. I have to add 3 to both sides. Yes, that's right. Thank you, Stephanie. Well, it's been that kind of day, huh? Negative 1x is greater than 1 plus 3, which is 4. Now, that's right. Thank you, Jenny. You remembered, because I'm going to divide by a negative number, right? I'm going to have to flip that symbol. So I'm going to have x is less than negative 4. Now, that obviously does not satisfy the condition, because we said x has to be greater than or equal to 3 halves. FYI, 3 halves, which is the same as, that's right, $1.50 for a sandwich, right? Exactly. 1.50. Good job, John. Always glad to have you talking. There you go. 1.50. So obviously, if you have $1.50, you don't want someone to say, "Hey, I'm going to try to con you and give you $4 for your $1.50." That's not going to work. So that condition kind of fails, but we are going to graph it eventually at the end to see what's up with that. Okay. So now we're going to go ahead and look at the next case. Next case here, we're going to have 2x minus 3 is going to be less than 0, right? We had it greater than 0, but now we have it less than 0. We had, remember, in the one in red, we had to make it equal to 0 because if you take the absolute value of 0, it's still 0. Yes, that's right, Tom. I'm glad you paid attention. So we're going to add 3 to both sides. We're going to have 2x is less than 3. Divide both sides by 2. So we have another condition here where we have x is less than 3 halves. So let's see if our condition is still going to hold up through if we're going to have x that's going to be less than 1.5. So I'm going to go ahead and take my problem. Now, instead of doing a +1, I'm going to do a -1, right, in front of the absolute value. Minus 3x is greater than 1. I'm going to go ahead and multiply this across. I'm going to have negative 2x plus 3 minus 3x is greater than 1. I'm going to go ahead and combine our like terms just like I did on the one in the red. So we're going to have negative 5x plus 3 is less than 1. I'm going to subtract 3 on both sides. So negative 5x is greater than negative 2. Now, just like the other one, I'm going to divide by negative 5. And just like in the red, I'm going to, again, that's right, James. Very proud of you. You remembered. We're going to flip that sign. So x is going to be less than 2/5, which is, of course, going to be $0.40. So I think 0.4, right, is definitely less than 1.5. So I think the one in purple might work. Now, here comes the part where we have to graph it to actually find our formal solution. So here's my number line. Forgive me for it being so crooked. I'm going to have 0, -1, -2, -3, -4, -5. And then on the right side, I'm going to go by fifths. So I'm going to have 1/5, 2/5, 3/5, 4/5, and then the whole 1. So I'm going to first do the one in the red for my first condition. It said it was -4. So we're going to put the red line, the red circle over there. Now, remember, it has to be an open circle, right? That's right. Good job, Jim. I'm sure you remembered exactly. Someone else can tell me. Yes. If it doesn't have a line under it, would leave it as an open mouth, open circle. So I'm going to go ahead and go here to the left. And I've satisfied that condition there by graphing it. Now I'm going to go ahead and do the other guy in purple, which is going to be 2/5. And just like that, we said x is going to be less than 2/5. I'm going to shade it all the way over to the left. So you notice right away we got something going on here. We have our solution. Going to have our solution because remember it said to solve. So indeed my solution, it looks like I'm going to have everything shaded in from 2/5 all the way to -infinity. See how it keeps on, the numbers keep on going on to the left as negative numbers, right? We know -6 is less than -5 because the further away it is from 0, the smaller the number is. So at the end of the day, I got my solution. Perfect. My solution is going to be -infinity to 2/5. Or you can write it as well the other way as x is going to be less than 2/5. This is my solution, and I am done with this problem. Please, guys, does anyone have any questions at all? I guess I did really well explaining, huh? That's cool. All right, guys, y'all take care. Thank y'all for stopping by. Please, if you like the video, if you like what I was doing, please let me know. I'm more than happy to explain. Thank you all. You have a wonderful day, okay? Stay safe.